part D. Now part D is down here. Question says, in the exam question, it says, use your answers from part B and C to justify that f has an inverse and state its domain. So I'm just going to graph this just to show you what it looks like. This makes sense from what we found our asymptotes to be. There's going to be x equals negative ln2, which was about here. And then there was a horizontal asymptote when y equals negative 2 and y equals negative a half. So firstly, fx will have an inverse because from our answer from part C, notice that f dash x, this function here that we have, negative 3e to the x, this will always be less than 0. This will always be less than 0. We can't get an answer here that will be greater than 0 because it doesn't matter what we sub in for x, there's going to be a negative numerator and a positive denominator. So as f dash x is greater than 0 in our domain, for x equals an element of our domain, therefore we know that it's always going to be sloping down. So therefore always sloping down. Now if something's always sloping down, it's not going to have any turning points, so it will pass the horizontal line test. If something's always sloping down, it's not going to cut twice if I do a horizontal line, so therefore its inverse function, it will pass the vertical line test, so therefore there is an inverse. So we can just state that it's always sloping down, so therefore does have inverse function. Now also we know that from our graph, one section of this is always above y equals negative a half and one section's below y equals negative 2. So that's our range for our original function. So we can just have a little sentence here. I'll put a sentence here and I'll pause it. Okay, so I put one branch is above the upper asymptote, these are the horizontal, and one branch is below. So with the first bit of knowledge and the second bit of knowledge, we know therefore f has an inverse. Now the domain, that's what it asked for, status domain. The domain will just be the range of the original function, and the range will be when it was less than 2 and greater than a half. So we're going to need to write that in terms of x now because domain. It's going to be negative infinity when x is greater than that but less than negative 2, or and it needs to be greater than negative a half. So x will be greater than negative a half and less than infinity. So this will be the domain of the inverse function.